Hello students, in this video we are going to solve one very important example in Newton's second law of motion. This example is been asked many times in the university examination, right? So let us read the statement of the problem. A bob of 1 meter pendulum describes an arc of a circle in vertical plane. When the angle of the cord is 30 degrees with vertical, the tension in the cord is 2 times the weight of the bob. So the tension in the cord is 2 times the weight of this bob. Find the velocity and acceleration of the bob at this position. At what position? When the bob is making an angle 30 degrees with vertical. So at that position, the tension in the cord is 2 times the weight of the bob. So this bob is having tangential component of acceleration. So it is swinging in vertical plane and normal component of acceleration towards the center. So first let us draw free body diagram of this bob. FBD of bob at this position, at the position shown when it is making an angle 30 degrees with vertical. So it is moving along a circular arc. So we are having weight of the bob mg. Weight is not given, the mass is not given, so we are assuming mass is m. And the tension in the cord say T, and this bob is having tangential component of acceleration AT, normal component of acceleration AN. It is directed towards the center of curvature. So taking x-axis in tangential direction, y-axis in normal direction, and resolving this mg into 2 components along x-axis in tangential direction and along y-axis, that is in normal direction. So it is given 30 degrees. So the component adjacent to the angle mg cos 30, the other component mg sin 30. Right? Now, summation Fx, unbalanced force in x direction, is equal to mass into acceleration. As per Newton's second law of motion, it is the tangential component which is acting in x direction. So what are the forces acting in x direction? It is mg sin 30. mg sin 30 is equal to m at. M gets cancelled. So at is equal to 9.81 sin 30. So the tangential component of acceleration is 4.905 meters per second square. Similarly, unbalanced force in y direction is equal to m into an. We are taking this as y direction. Normal component is acting in y direction. So what are the forces acting in y direction? Plus T minus mg cos 30 is equal to m an. But it is given that the tension in the cord is 2 times the weight of the bob in this position. T is equal to 2 mg. So replacing T with 2 mg minus mg cos 30 is equal to m an. Right? So taking m common, you can cancel. So it is 2 into 9.81 minus 9.81 cos 30 is equal to an. So the normal component of acceleration an is given by 11.12 meters per second square. Now we have to find out the velocity and acceleration of the ball. Resultant velocity and resultant acceleration. So for resultant acceleration we have at and an, from which we can find out the acceleration. So to find out the velocity we can make use of the normal component. So the normal component of acceleration an is equal to v square by rho. Rho is the radius of curvature, which is 1 meter. So an is equal to 11.12 is equal to v square by 1. This gives you v is equal to 3.33 meters per second. So this is the velocity of the ball at this position. And the resultant acceleration or total acceleration a is equal to square root of at square plus an square. So at is 4.905, an is 11.12 square. That gives you 12.15 meters per second square. So that is the acceleration of the ball. Understood? So we have covered almost all types of examples in Newton's second law of motion, rectilinear as well as curvilinear motion. Thank you.